Hi everybody, Mr. Pistone here. I'm going to go over practice 5.4. This is your homework. The directions say in the problems below, assume that the acceleration due to gravity is negative 9.8 meters per second squared. That's negative 980 centimeters per second squared in the downward direction, unless otherwise stated, and use consistent units. Using consistent units means if it's given to you in kilometers, you probably want to convert it to meters. If it's given to you in centimeters, a distance value, you want to convert it to meters as well. Alright, problem 1. It's referring to this tree over here on the right. A coconut falls from a tree that's 12 meters high. How much time does it take to hit the ground? That's question 1. Alright, so first thing we do is, okay, what are we looking for? It says how much time. So a lot of times I'll underline what I'm looking for. Look for how much time, so write that down. If I'm looking for time, write down the time formula. Now, there are two formulae that I could choose to solve for time. Alright, why did I choose this one? Well, this one includes a distance value. Okay, if we look up here, this time formula does not include a distance value. It says time is equal to the change in velocity over acceleration. That's a true statement. But if it doesn't include distance over here, I won't be able to account for the fact that this thing was 12 meters off the ground. And we know just conceptually that if we drop something from a higher position, then it's going to take more time for it to hit the ground. So time is obviously a very important variable. Distance is a very important variable here in solving for time. So I'm looking for time. I'm going to use this formula because it includes d for distance. This reads time equals the square root of 2 times distance divided by g, or gravity. Alright, they gave me the distance. I wrote that in my given section. D equals 12 meters. Gravity is assumed. They gave that to me. We are on the Earth. And now let's plug these values in. Time is equal to the square root of 2 times the distance, which is 12 meters, divided by gravity. Alright, so we'll plug those values in. That's the square root of 2 times 12 is 24, divided by 9.8. Okay, this is going to equal the square root of, now this is about 20, this is 24 divided by about 10. So it's going to be around 2.4. Okay, it's going to be around that. So when we go ahead and do our calculation, that's what we should be looking for. Okay, then make sure you take the square root of that. I think the answer turns out to be one. Well, I'll leave that up to you. I think it's 1 point something of the final answer, but we'll let you solve that. All right, question B: how fast is the coconut traveling when it hits the ground? All right. Something else that we should get conceptually is that, again, the higher you drop something, the faster it's going to be when it hits the ground, because we know that an object is accelerating, so it's gaining speed as it falls, so it'll be faster the higher you drop it from. Alright, so again, that distance is going to matter, the fact that it's 12 meters off the ground. So I'm looking for VF. That means I'm going to write the VF formula, okay? So I'm for V final. Alright, let's see. Velocity final is right here. Equals velocity initial times, velocity initial plus acceleration times time. So that's going to be my formula. So let's write that down. Velocity final is equal to velocity initial plus acceleration times time. Now, given section, they have to give me these three things. So velocity initial, I think it said that this object was just, okay, so it fell from a tree. So the initial velocity was when it was attached to the tree, so that would be 0 meters per second. Acceleration due to gravity, still 9.8 meters per second squared. And time, well, how long did the coconut fall for? In other words, how long was it in free fall for? That's the answer from question A. So you'll have to get this answer up here. So once you solve that, that becomes your time value. Okay, and then go ahead and solve. Letter C, draw a diagram that qualitatively, that means no numbers, indicates the coconut's velocity and its acceleration when it is midway and when it is just above the ground. This is a motion diagram. Okay, this object is moving on the vertical axis. So I'm just drawing an arrow to the left to say, okay, let's draw our motion diagram where we have a little more space. I'm going to have my reference line pointing upwards, because up has been our convention for positive. Okay. Coconut starts in the tree, right, and it says make sure you indicate the coconut's velocity and its acceleration, okay, when it is midway and when it is just above the ground. Okay? Alrighty, this is a very interesting question. If rain falls from a height of 2 kilometers, okay, up in the clouds, how fast should it be hitting the ground? Okay? So let's solve that. Let's say, okay, rain falls from 2 kilometers. That's 2,000 meters. Okay? Up in the sky. Rain should be hitting us very fast. It should be hitting us at a very high final velocity, and therefore should really hurt or really cause some damage. But that's not the case. Rain doesn't really hurt when it hits. So the first question is saying, if it falls from this height, which it does, how fast should it be hitting the ground? Okay? So how fast should it be hitting the ground? Sounds like we're looking for a final velocity. So look for final velocity. Now when you get your answer, I want you to consider how big that number is. Okay? And think, well, I know rain doesn't hit me at that velocity, but why not? Okay? And then I threw in this conversion for you, because you're going to want to use 2,000 meters and not 2 kilometers. Okay? Okay, here's one where an apple falls from the top of a tree. It takes 2 seconds, so this time they gave you time to hit the ground. What are we looking for? How far? So now we're looking for distance. Okay? So you want to choose a formula that solves for distance, and you might have to manipulate one of those. Not sure if we gave you one that solved for distance over here. No, we did. There it is. Distance is equal to gravity times time squared divided by 2. You might also see this formula written as 1/2 AT squared or 1/2 GT squared. Alright, when it's 1/2 multiplied by something, that's the same thing as dividing by 2. So you'll see that expression a couple different ways. Alright, so solve for D. B, calculate the velocity of the apple just before it hits the ground. Alright, so if you're going to calculate velocity final, go ahead over here and we'll solve for velocity final, which equals V initial plus A times T. And question 4, if you threw a ball up in the air at a velocity of 120 centimeters per second, what will its velocity be at the highest point? How much time will it take to get to the highest point? And how high is the highest point? Alright, what are you looking for? What they give you, formula and solve. Okay, let's look at this picture that I drew over here. Okay, so here's the ball that gets thrown up in the air. They're asking you, okay, what is the velocity at the highest point? How much time did it take to get here? Question B. C. How high is this highest point? And then, how much time does the ball take to come down from the highest point? Okay. What's the ball's velocity when it hits your hand again, back here? Okay. So take all that given information and go ahead and solve that problem. So also remember 1,200 centimeters per second is going to be the same thing as 12 meters per second. Okay? And 12 meters per second is faster than a very fast high school sprinter or college sprinter. Very fast person. This is going to be a little bit faster than that, just to put that in reference. And this is you throwing a ball up in the air.